Hello there, guys. Welcome to today's recording where I'm going to explain my team's ONDC solution for negotiation engine. So, we thought a lot about it, and what we came up with is kind of flexible solution which involves more input from user. So now ONDC is going to be used by everyone, like all types of negotiations. So we can't build an inbuilt model which will determine what are the interests of the user, of the buyer and the seller. So what we made over here is kind of like evaluation of each other. So let me start off by explaining buyer mod. It's a schema. So buyer name will be there, location from where they are going to buy, their preferred categories, total purchases. Now, the total purchases and reviews, these two details are for sellers to see if the buyer is genuine or not. And like if total purchases is a lot and the reviews show no red flags, then it means like the buyer is quite veteran buyer. So their model, s- seller's model can say, yeah, sure, we can be a bit flexible on our order, on the payment cycles and stuff. But like if a buyer is completely new, there might be a different needs from seller. That is like advance payment of 50% or something like that. Like if buyer is veteran, you can give a bit of slack over there. But if they are brand new, how do you trust them? So these two details are for seller. Similarly, seller schema, again, name, location, a rating for them. If the buyer is buying from, it's the same thing around from buyer to seller. Now, from buyer's perspective, if a buyer is buying from some seller, they can check the rating. If the rating is good, if it's bad, they can make adjustment to their terms, like ask for warranty or return policies and stuff. Hold reviews as well and number of products sold. Again, same thing as over there. This is a dummy data of what seller might look like. Name ABC, location city Mumbai, India, rating 5 on 5, products sold 5 products, active since as well. Again, to see if a seller is genuine or not. If they have just come up yesterday or today, so you need to be a bit cautious about the negotiation. Anyways, going ahead. Now, the next model is negotiation model itself. Ignore this for a second. You might not understand it. So in negotiation model, we are importing the seller and buyer schema that we prepared over there. And we are declaring product details. Now there are two types of details in our negotiation: product details itself and the negotiation details. All right, I'll explain these. Let's start with product details first. Product details, this is gonna be a definite field, right? Product name is not gonna change suddenly in between the negotiation. So we have made this required as true. Product description as well, product category, and after that are the things that can be negotiated. So like price history. What we mean over here is now first the catalog will be sent by seller to buyer. So in this number type array will have a value by seller. Then the buyer will counter their value and add to this array. So like over here, now you notice number schema is used. What we mean by number schema is it will have a value that is the number. Then it will contain a enum of seller or buyer, meaning like who proposed this value. So the buyer apps and seller apps can see like what am I proposing and what's the proposal by the other team. And timestamp again on it. Same thing is the string schema. This is a for things that don't have number value in them. Like I'll show you ahead. Anyways, price history is a number schema. Quantity as well. Like thing is the reason I said that we have to depend on the apps themselves to see what's in their interest. Now let's suppose someone is planning to buy a very big machinery, like a construction site machine or some huge mining operation machine. So in that case, quantity is gonna be less. But like if someone buyed one, that's okay. Seller would be like, okay, yeah, we are not gonna give you a big discount. But someone buys two over here, so it's gonna be a big thing for them because two machines at that time slightly better than one only. It shows commitment towards the seller, so they might negotiate a bit more. They give them discount higher than what you would give to one only one quantity. But now let's take a something small scale. Like someone is planning to buy shoes. Someone placed an order of like 10 shoes. The quantity, if we compare it to that mining operation trucks, it's massive. Five times what over there mining truck was considered massive. But if you think it in terms of shoes, 10 is like nothing. Wholesalers will take 50, 60, something like that. Minimum, I'm saying, not even that, maybe 100, 200. But yeah, that's why we said that embedded intelligence is there to determine if the negotiation is going in correct direction or not. But overall, our mechanism to tackle all this. See, I'll explain to you. But meanwhile, let us just show what all things might contain. Quantity, again, array which will store entire history. Warranty, discount, financing, buyer finder fee, commission, settlement window. Now, this financing is a string type schema. Who might finance? Because this doesn't accept number. Alright, that's why we declared string schema up there. Commission, settlement window, settlement cycle, performance standards, jurisdiction, disputes, liability. Now, all of these are optional fields. They might want to put some values in there, they might not want to. It's up to the buyers and sellers. Next up, negotiation details itself. Now this is where we have put our logic, our solution to this exact problem. What we thought of over here was when a seller first sends the template to buyer, the buyer app's intelligence will evaluate if the template, if their offer, on what level they are satisfied with that offer, and based on that they'll assign a score to it. This score will be from 0 to 100, meaning 100 they are very satisfied with the offer, 0 they are not at all satisfied with the offer. And now once they start trading with each other, back and forth, not trading, negotiating with each other back and forth, this value should inherently increase. The apps might see that okay, others value is this much, so I should give it a bit of slack but keep my interest as well. So this value, as they increase, the apps may find that okay, this offer is acceptable to me, they'll put satisfied over here. Now you might say okay, sellers put satisfied over here, and also what we have done is there can be only back and forth, no back. Like no seller can send negotiation details two times. It has to be like seller once and then buyer, then seller, then buyer. The buyer can't be skipped or the seller can't be skipped. There has to be one only. So You might say, okay, in back and forth, what if seller puts satisfied and the buyer manipulates these values and puts satisfied as well? So we have disabled that. You can, if seller puts satisfied, what you can do is only put satisfied from your side or make changes to the term again. If you make changes to term again, seller automatically goes back to unsatisfied state. Same thing happens with the buyer as well. This is a protection mechanism so that the other app doesn't get cheated. And yeah, basically, there are three states to the negotiation. Open, closed means the negotiation wasn't heading in correct direction, so it was closed by our embedded intelligence. And successful, it happens when both of them put their satisfaction to satisfied. I'll explain this alert sent later on. Now let me explain you our endpoints. The negotiation endpoints are pretty simple. One is to create negotiation, other is to fetch negotiation, only fetch. The next is, this is for development purposes only, to fetch all negotiation. Another is update negotiation, in which the actual back and forth will happen. And another is delete negotiation, in case you want to delete a negotiation. We have put a limiter over here. The limit is each IP 100 requests per 15 minutes, so that our system doesn't get DDoS attacks or something like that. Also, to verify our inputs are in correct order and there are no NoSQL attacks in them, injections, sorry, no NoSQL injection attacks in them. We have used JOI module in Node.js to verify that everything is correct, is in correct type. That is, who is string, and the valid input it accepts is seller and buyer, and all the things like that, so that the system becomes a bit proof from no SQL attacks. We tried our best. Still, if you find some error in it, we are all ears. I was explaining negotiation endpoints. Okay, so now let me show you the logic behind it. Negotiation controller. Now over here, create negotiation. For creating negotiation, what we have for handling errors as well, we have used Winston to log all the errors that we might receive. Anyways, first off, we validate if the negotiation body is legitimate or not using our GOI validation thing. Once we have validated the body, we fetch the all the things from the request body. And in request body, you need to only mention the buyer ID and the seller ID and rest of the negotiation data. This will fetch the buyer and seller details using their ID. Next, we'll check if that ID is genuine or not. If they are not, we'll return back error. If they are genuine, we insert it into a negotiation object. We save it and return that negotiation was created successfully. Next up, get negotiation, pretty simple logic. You ask the parameters. In parameters, you have ID, the negotiation ID. If it's genuine Mongoose, that is MongoDB ID, it will first validate that or not. After that, it will simply, if there is indeed genuine ID like that in our database, it will simply fetch that. If again, it's the ID is in MongoDB type, but there's no data linked to that ID, it will simply return no such negotiation. If everything is in order, we simply send back the negotiation data in JSON format. Again, if in all of this there's error, we'll log this in Winston. Now, update negotiation is where the real power of our program is in. This is the same from create negotiation. We first validate the body, then if there is any error, we log it into instant. Then we try to fetch details, check if the ID is genuine or not, check if the negotiation exists for the same ID or not. Then we check if the negotiation state is closed or successful, in which case you can't update the negotiations, right? So we return that negotiation is already closed and cannot be updated. Once we have checked all these things, we can move on to the logic. Over here, we check if the body contains only the allowed updates. Allowed updates are the type which are in array. Remember, I said you can't update product name or details. So this is what is being checked over here. Next, we check if like all update parameters are allowed. If they aren't, we return error. Next, we'll check that whose turn it is and is the person who is trying to send the negotiation details right now updates is the person who has the turn or not. This over here checks that if it's their turn, it goes into this if block, and for each update the update gets pushed into their respective array. Next, we update the buyer and seller scores in the body. If any one of them which will be updated, but yeah, we basically push that. If they updated their in their body, it contains satisfied, we push it into database. If similarly for buyer satisfaction as well. And once we are done, we switch the turn to the other person, the other entity. Now over here, after that, we check that thing I said, ki like if someone sends satisfied with a body, then we'll deactivate the like we'll make the other person unsatisfied. So this is what's happening over here. Then this entire thing, we are using a flag variable to ensure that's what happening over there. All of this code is uploaded on GitHub, so you can go and see it over there. Now this is where our embedded intelligence comes into play. After every fifth iteration, we check if the negotiation is going, is it converging, is it diverging, or it has gone into stale state. How do we determine that? We check the scores, seller scores and buyer scores. So if you look over here, we have used called the function check negotiation status. This is in our embedded intelligence folder. Ignore these mails over here for a sec. Yeah, this is our function. We fetch the buyer score, seller score. We ensure again that it's the fifth iteration. Now over here we calculate the percentage change from the first iteration to the sixth iteration. That is the current iteration to the last time we checked. If there is no last time, then to the first iteration. And what we basically see over here is that is there a score above 75 for both the entities. If both the entities have score above 75, there's less likely to be growth in their satisfactory scores. So for that, we'll check only 10%. So like if the growth is below 10%, what we do is send alert to them that warning is being sent. Please try to conclude your negotiation soon. Else, again, after fifth iteration, we'll check that has there been incremental growth in your negotiation. If the growth is about 10%, then we'll let them continue. If the growth again is below 10%, meaning it's somewhat flatlining, we'll terminate the negotiation. So they get one alert. After that, the terminate negotiation function gets called. over where we terminate the negotiation and send mail to them that your negotiation has been terminated due to no significant change. Now, if the score are below 75, means there should be incremental growth. So over here, the criteria is that their score improvement should be about 25. If the score improvement is about 25, we do nothing. The check negotiation does nothing. If it's below 25, the same thing which happened above will happen over here. We'll send an alert to them once. If there's still no significant improvement, in which in our case it's 25% above, then we'll terminate the negotiation. This up here is just the logic to that mailing system. Send alert, terminate negotiation, and send successful. In terminate, we basically change the state of the negotiation to closed and send an email to both the entities that negotiation has been closed due to no change in score percentage. And yeah, basically that's it for the code explanation, at least the important bits. In this next video, again, we'll be posting a video with this one. In that, we'll be showing the test cases implement. And yeah, see you in the next part 2 of this solution explanation. Thanks for watching.